Hey guys, this is the 8th grade video lesson for Tuesday and Wednesday, which is the 17th and 18th of November. A couple things just to be on note. Number one, the Unit 2 quiz proportionality is up and live. It is due by Sunday. If you have had a chance to look through it, you know that's a really fair test. Really focusing on this idea of what's proportional, what's not proportional, looking at tables, looking at graphs, looking at equations, discovering what the constant is, which is now the slope. And I think that if you, after the first attempt, if you have any questions, please reach out to me. You get 2 attempts on the test. We're going to take the highest score of the 2. So please work on that quiz. I think we've got about 30% of you guys that's done it so far. All right. So what is I talking about today and yesterday? Well, yesterday you guys should have been, if you were at home or for any reason, you should have been working in the Google Classroom, slopes and triangles. So if I go to that Desmos activity, I'm going to open up that student preview. We're going to talk about it in a few seconds if you haven't done so. The first slide is really just what do I remember about slope. So again, we're going to use the draw tool and we're going to draw something in there, write something in there, give me some sort of symbols to kind of help me to understand what I know about slope right now. And then what do I know about positive slope, negative slope, zero slope, and undefined slope. If you were not here previously, the last video talked about that. Okay, so now we're moving on to slide number 2. Again, we're talking about this idea of slope. If I was going to count blank units up and blank units to the right, what would that look like? So for this example here, if I want to go between A and B, I would count 2 up and 3 to the right. So I write that in there. So if that was 2 to 3, what would be to CB? And what do you notice about those triangles? Slide number 3 talks about those triangles a little bit more. So we're talking about what is a slope. Number 4, again, here's a different type of a line and a different type of slope. So what do you think the slope is for this one? Again, we have multiple points. You only need 2 points to be able to find the slope of any line. So what would that slope be? Number 5, again, when we talk about find clean points, I've given you a line here. You got to find a clean point is a point that crosses a line perfectly. So I'll give you an example. This would be an example of a clean point because it falls right on a X and Y grid axis. All right, there's no in between for that. So if I find 2 of those, I'm going to be able to find the slope of that line. Then you get slide number 6. Here's another line. Tell me what is the slope of that line. Check your answers. Number 3, number 7, multiple choice. Number 8. So what you're going to do is you're going to be creating some slides here. The goal is to make them smooth. So if they were smooth, this is what it would look like. Right into the water, right? No breaks in that one. All right, an example of a broken slide would look like this. All right, and they won't be able to slide down. So the next few slides are going to be really about you creating, dragging slides to make sure that they will be smooth slides. Sometimes they're going to give you dimensions. And you're going to have to ask yourself, would those similar triangles create the slide that will make you go down? Are they similar? Here we got to fill in some of the blanks and so on. So that was your work from last night. It is an effort and engagement piece, so make sure that you do it before Sunday. In classwork, so we started off with this linear Desmos intro activity, which again goes into this idea of creating slopes based on equations. We did have a Desmos graphic calculator up, and I'm going to put that up there real quick for you guys. This Desmos thing allows us to put equations in, and with those equations, we're able to see what happens. Next year, you're going to be getting a ton of, you're going to be getting a new calculator. It's like a $130 calculator. It's all for graphing. This does the same thing on Desmos, but you're going to want that handheld one prior to that. So I'm going to put an equation right here. Y equals X, and we call this the parent function, okay? This is the parent function because Y equals X has a value. It is Y equals 1X. So when we think about this idea of the value here, This number outside of the x is what we call m, which is the slope. Okay? The slope is referred to as the rise over the run. Well, you're like, well, how could I have a fraction here when I have the whole number? Well, remember, I could create that into a whole number, right? I could say that's y equals 1 over 1x. So the 1 would be the rise, and the 1 in the denominator would be the run. So if we think about this, every time I rise up 1 and run 1 to the right, it's going to intersect that line. Rise 1, run 1, rise 1, run 1, rise 1, 1, 1. They all follow the same pattern, the same constant. All right. So when we think about this parent function on that Desmos activity, that's what you're going to build everything off of. We're going to compare this parent function line to all the other lines on that CAMI assignment that you're supposed to be working on at home. All right. So let's go to that CAMI assignment. All right. Here you see that parent function line there already. All right. And that's going to be that comparison piece. Now they're saying, well, what happens if I change that parent function equation? I'm going to go from y equals x to y equals x plus 7. So the slope of 1 or 1 over 1 doesn't change, but what does change is this, the y-intercept. Remember, this is non-proportional. And it's non-proportional because I do not go through the origin like I do with my parent function. So what this tells me is, where does that line go? Well, it goes at 7, right? On the y-axis. So I'll go 5, 6, 7. And then I continue to have that same slope from that point, up 1 over 1, up 1 over 1, up 1 over 1. All right? And I can use that line then to create a new line. Okay, and you'll use a ruler. Here you'll be able to draw lines on CAMI to make it a little bit easier. You go to this Shapes button. This is your line. You can go up here and change your font, the size of your line that you want to. That's where it's going to go. So how is it different? Well, the description of that is it's 7 units up from the original one. The slope still stays the same. They're parallel, but I've shifted it 1, 2, 3, 4, 5, 6, 7 up. The next one, same idea. What's my y-intercept? Well, I went from y equals x with my parent function to y equals x minus 6. All right. In this situation, this is the part that changes. All right. My y-intercept now is at -6, which is down here. But again, I still follow the same 1 over 1 function. Up 1 over 1, up 1 over 1, up 1 over 1. And I can use that to create a new line. So how is it different? I shift it 6 units down. That's the difference between that. All right. Then the next one, y equals -x. So think about this. If y equals x is 1 over 1, y over -x would be y equals -1 over 1. So if I think about that, that means I'm going to be kind of doing the same thing, but instead of going in a positive direction, I'm going to be going into a negative direction, because a negative divided by a positive is a negative. So if I start at the origin, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And this is this rise over the run that we have here. Okay, but it's a negative rise. So when we think about it, I now have a line that looks like that. It's a reflection. It's a reflection of the line. So what I like you to do now is take the last 2 problems on that paper, and I want you to graph them, right? So think about in terms of what that slope means, whether it's y equals 2x, how would I represent that as a rise over run? Y equals 1/2 x, how would I represent that as a line of rise over run? Okay, so that talks about the first page. The second page is just a little bit more work, just thinking about what are we doing with our numbers. Put this back here. Well, you guys are all doing well. I got a table here. so if I know what x is and I substitute x into any of those equations, you should be able to tell me what y is. All right, so I'll give you a couple examples here. If y equals x and x is -2, then y equals -2. For this one, for 0, y equals 2x, y times 2, x would be 0. All right, that's how we'll do that. Sorry about that, I had a slight interruption. For 1, all right, if I take 1 and I multiply it and y equals 1/2 x, 1/2 of 1, y would have to be equal to 1/2. How about 2? In this situation over here, we're going to put it into the equation. If this is x, this would be y equals the slope times 2. All right? And then 4, you've seen all the other examples that are up there. And then finally, we just have key changes, just make some observations. How does changing the value of m change the graph? How does the line change? That's that question down below. And then the last 3 problems are just challenge problems. I'll give you an example. It says, write the equation of a line that is shifted up from the parent function. So if I'm shifting up, that means I'm moving up on the y. If I'm shifting up, I might say x plus 8. I'm 8 from that original parent function. The last 2 pages, again, you don't have to do right now. Those are going to be talked about at a later date. So we're really just focusing on the first 2 pages today. All right. So where does that bring us for the rest of this period? And I think we pretty much covered it all. Work through those. Submit it when you're done. That way we know that you're all set and ready to go. The answer key is there for you. If you have any type of questions, you want to check your work before you submit that work on Canvas. Okay? And that's it. Hope everybody's doing well. I'll send this out to you via email. If you have any questions, let me know. Bye.